What's up guys, it's me again, Chemical Engineering Guy, and I'm going to show you in this course, or this block, TD2, about pure substances. And it's a very important topic because we're going to be speaking about how to model substances, understand phases, and many properties of how substances, or essentially pure substances, differ from mixture of substances. Remember that this course is a lot of theory and then we're going to apply it, and this is also the case. Actually, this one has a lot of theory, a lot of concepts, but you may be able to apply it very easily in the real life problems in engineering, and also in real life in your house or the school, university, wherever place you are, you could actually apply those concepts. So we've seen this one before and TD1 before. Should get all these concepts already, know them. We're right now on this part, which is TD2, pure substances, and even though it's not that much, or it seems not that much, it is actually a lot of concepts and theories. So we're going to take a little bit of time studying this block right here. And once we get what's a pure substance, we can actually start our study on the first law, second law, entropy, and finally application of that laws, such as production of power and refrigeration or liquefaction. So what are we going to see exactly is this block, TD2, pure substances, is broken down into 5 sections. Section number 1, which I think is the most basic one, it's properties and pure substances and phases, etc. Then we change to section number 2, which is essentially speaking about phase diagrams, pressure versus volume, pressure versus temperature, and many other interactions such as this three-dimensional diagram of pressure, volume, temperature. We're going to see a lot of points such as critical point or saturation, etc. We continue then with section number 3, which is the vapor tables. How do we get data of water vapor or even saturated vapor, liquid, and subcooled liquid, etc. And we're going to make a little introduction to refrigerants, since they are also pure substances. And it's very important because these ones right here, probably we're going to use them in power generation, and refrigerants we're going to use it, as the name implies, in refrigeration systems. And once we get the idea on how to get data from tables and refrigerants, water vapor, saturated vapor, enthalpy, entropy, specific volume, saturation temperature and pressure, all those important data, we will continue on the modeling on gases and state equations. Essentially the ideal gas, which probably you work already with, the C compressibility factor, Period equations, and van der Waals equation, and many other equations that are very useful to model real gases. And last but not least, we're going to start our formal study on enthalpy and heat effects. What's these heat effects? We're going to start studying what's enthalpy of formation, enthalpy of combustion, enthalpy of sensible heat, enthalpy or latent enthalpy, or latent, all that terms that we're going to be using enthalpy with are going to be introduced. But I just want to let you know that the most important ones are going to be sensible heat, which is the one that is affected by temperature, and latent heat, which is the one involved in the change of phase. What's up guys, it's me, Chemical Engineering Guy. So if you like the video, why not push the like button? It really helps me to know if you're liking the videos, or if I should be changing something, or I should be adding something, taking out content, whatever. Also, sharing is caring. So if you got any kind of friends, teachers, colleagues, or whatever kind of person that might be interested in this type of content, why not share it? Sharing helps our community to grow faster in members and in content. If you want to keep track of my activity, videos, uploads, experiments, playlists, whatever content I'm getting on YouTube, be sure to click the subscribe button. Subscribing to the channel is totally free, guys. My dream is to create an online academy of chemical engineering, where everyone can access it in the world. Imagine a place in which the student, the teacher, and the engineer get the best of each other. So thank you guys for the support and the love.